Right, question 15. Find algebraically the set of values for x which, and then we've got two quadratic inequalities. So our method for this, we don't really need the calculator for this, hopefully anyway. Depends whether we need to use the formula to solve, but I don't think we do. So if I start with this inequality first of all, so I'm going to find where it's equal to 0 first of all. So I'm going to say x squared minus 49 is equal to 0. So that's the difference of two squares. So I've got x minus 7 and x plus 7 is equal to 0. And in effect, so that gives us two values for the solutions. Those either x is equal to 7 or x is equal to minus 7. And what that actually means is if I were to plot that as a quadratic equation on a graph, I would have two solutions, one at minus 7 and one at 7. We don't need to worry about the x coordinate, but the bit of the graph that I would be after is where the graph is greater than 0. So the graph is greater, this is the 0 line, so the graph is greater than 0 along this line here and this line here. So in terms of an inequality, the regions that would satisfy this graph alone, or this inequality alone, are when x is less than minus 7 or when x is greater than 7. And then I'm going to do exactly the same thing for the second equation. So I'm going to solve x squared minus 31x minus 72 is equal to 0 first of all. And it could be that we need to solve, we'll try and factorize it first of all. I'm not sure why that's just switched colour. Let's switch back to red, keep it consistent. So I'm going to try and factorize it first of all. So the fact that we've got a 5x here, the only way we can make a 5x is with a 5x and an x, because that's the only way we can make a 5x squared. And then we're looking for, in effect, factors of 72. So factors of 72, 8 and 9 first of all. If we try 8 and 9, 8 and 9 work perfectly actually, because if I have a I'm looking for, in effect, so I've spotted it, but let me just explain how I've done it. I'm looking for two numbers that multiply together to make 72, and then because of this 5 lots of one of the numbers plus the other number add together to make minus 31. So I know one is negative and one is positive. I know, and I've said 8 and 9. If I do 5 times by 8, that would give me 40, and then minus 9. So in effect, I want minus 8 and plus 9. And then I'll just go over that again. Sorry, I've put my minus in the wrong way. So 5 times minus 8 is minus 40, and then plus 9 would give us minus 31, and then minus 8 times by 9 would give us minus 72. So I need my minus 8 in my bracket opposite my 5, so minus 8 there, and my 5 in the bracket, and my 9 in the bracket with that. That leads me to two values for x. To make this bracket 0, x would need to be equal to minus 9 over 5. And to make this bracket 0, x would need to be equal to 8. Just to help me out here, I'm going to just say that that's going to be equal to minus 1 and 4/5. And then I'm going to do like what I did here. I'm going to, in effect, draw a rough sketch of the quadratic. It's going to cross at 2 points. Those 2 points are going to be minus 1.8 and 8. And this time I'm after, the area where the graph is greater than 0. So the area where the graph is greater than 0 would again be this section here, which is when x is less than minus 1.8, or the area where x is greater than 8. X is greater than 8. So now if we think, if I drew a number line, and let me just kind of, for my explanation, I want to go from minus 7 all the way up to, let's say, 10. And then I'm going to put both sets of inequalities on. I should have really been a bit more careful with my colours. So I want where x is less than minus 7. So that would be that section there. And when x is greater than 7 would be that section there. or when x is less than minus 1.8. So that would be, if that was 1.8 minus 1.8, that section there. Or where x is greater than 8. So that would be that part there. So which satisfies both would be where we've got a double line. So that would be this region here and then this region here. So that satisfies both. I would need to x to be less than minus 7 or x to be greater than 8. Yeah. So let's just move that line down a touch. I'll just write it in again. So x is less than minus 7, comma, or x is greater than 8. Okay then, marks for that then. So let's see whether mark scheme agrees with me. Okay, it does. So A1 for my answer. So M1 for identifying the correct regions. And then we've got it's suggesting an M1 for at least 2 of the inequalities. So M1 can be awarded there. And M1 for factorising this one. And then an M1 for either factorising, or you could have done it by complete. You could have done it by completing the square, but by quadratic formula for the 5 marks. Yeah, there we go. Okay then, question 16. So describe fully the transformation that maps S onto T. So S onto T. So straight away, draw an arrow just to indicate which way you're going. So to go from S to T, I pick a like point. So let's pick this point and this point. To get from here to here, I would need to go that way and then that way. So it's going to be a translation because the shape hasn't really been moved or rotated or enlarged or reflected. So it's a translation, and then I would state them by, and I'd state the vector. So if I've gone from there to there, my change in x is going to be 1, 2, 3, 4, 5, minus 5 because I've gone 5 to the left, and then I've gone 2, 4, 6 up. So that's my translation. Well, that's my vector. Okay, and marks for that then, it is a B1 for translation stated, so translation B1, and then a B1 for the vector. Okay, and question 17. The functions g and h are such that, and then you've given 2 functions, find g of 16. So in effect, we're starting with the function of g, cube root of 2x minus 5, and then we're saying that the g of 16, I'm substituting in x as 16. So the cube root of 2 times 16 minus 5, so it's going to be the cube root of 32 minus 5, 27, and then the cube root of 27 is 3. Right, for part B, find, I'm sure we did a very similar question to this. Okay, interesting combination. So we're trying to find the inverse of G, and then we're putting that into H. Okay, so if I start by looking at, if I say G and I call it, instead of a function, I'm going to call it Y. And then I'm going to rearrange to make y the subject, and then that's the equivalent of taking the inverse. It's just a neat way of doing it. So y cubed is going to be equal to 2x minus 5. So x is going to be equal to y cubed minus 5 divided by 2. And then, so for that to be the inverse, g to the minus 1 of x is equal to x cubed minus 5 divided by 2. Now I need to put this value in for x into h. So let's just write h again. So h is equal to h of x is equal to 1 over x. So h of, and I'm going to write it this way purposefully, h to the minus 1 of x is going to be equal to 1 over x cubed minus 5 over 2. So in effect we're multiplying by 2, so it's going to be 2 over x cubed minus 5. So I'm looking at 2 over x cubed minus 5. And that's it for that question. So we'll go to the mark scheme and back to part A. So for part A, it is just a B1 mark for 3. So B1. For part B, M1 is given for the method to find an expression for g to the minus 1 of x. I thought that was the majority of the question. So M1 there, and M1 for given to find an expression for h g to the minus 1 of x. I missed that bracket there, but we've got M1 there, and then an A1 for my answer. Okay then, and question 18. So a circle has an equation of x squared plus y squared is equal to 12.25. The point P lies on the circle. The coordinates of P are 2.1, 2.8. The line L is the tangent to the circle at point P. Find an equation for L, given your answer in terms of AX plus BY plus C. Okay, so in effect, so circle is centered at the origin, and we're looking for, in effect, we've got P there, and we want to find the equation of the line. So the first thing that we're going to do is we're going to work out the gradient of the line between the center of the circle and point P. So that's going to be equal to, and it's quite nice, 2.8 minus 0 divided by 2.1 minus 0. And so we can say that's the same as 28 over 21, which is 4/3. So the perpendicular gradient, or the gradient of L, so I'm going to call that ML, is the negative reciprocal, so it would be minus 3 over 4. And then we know that it passes through this point here, so we know the gradient and we know a point, so we can say that y is going to be equal to minus 3 over 4x plus c, but passes through the point 2.1, 2.8. So when y is 2.8, x is going to be 2.1. So we'll rearrange that fairly quickly. So I'll bring my calculator back up. Okay, so I want to do so I want to do 3. So 3/4 times by 22.1. As a decimal gives me that value, and I want to add that to 2.8, so plus 2.8. So all I've done there is, in effect, that would have been minus that value, and then I need to take it over to the other side. So we've got currently C is equal to 35 over 8. Okay, and then we want to put it in this format. So those of you that go on to A-level, you will learn a slightly different method for this, but if we're rearranging from this point though, we're saying that y is equal to minus 3 over 4x plus 35 over 8. If we times through by 8 as a starting point, we get 8y is equal to minus 6x plus 35. And then we need to take 6x over to the other side, so we're looking at 6x plus 8y is equal to 35. Okay, and if we go to the mark scheme then, so the mark scheme says it is an M1 for finding the gradient of 4/3. It is then an M1 for taking the negative reciprocal for the gradient of the line L. We've then got an M1 for substituting in the coordinate to find the value of phi, and then an A1 for the answer. Okay, right, question 19 then. The ratio, another ratio question then. So the ratio of Martin's hourly pay to K's hourly pay is 6:5. Both of them get an increase of 1.5 on their hourly pay. The ratio of Martin's hourly pay to K's hourly pay has increased to 13:11. Okay, I'm going to do it like this. So I'm going to say M to K. They kind of start at 6:5, but I've got to add yeah. So the issue is I can't just add on 1.5 because 1.5 is there is the figure. I can say whatever multiple of this, so let's say x plus 1.5. So those ratios would be equivalent to those ratios. So if those ratios are equivalent, we can in effect say so I can kind of do it however I want, I believe. Yeah, that would work. So I could say that 6x plus 1.5 over 13 would be equal to 5x plus 1.5 over 11. And then if I cross multiply, no, I don't think that's right. Let me just change that. Those ratios, what I'm going to say is 6x plus 1.5 over 5x plus 15 is equal to 13 over 11. Now if I cross multiply, that's better. So 11 lots of 6x plus 1.5 has to be equal to 13 lots of 5x plus 1.5. So that's going to give me 66 plus 11 times 1.5 gives me, we'll leave it as 33 over 2. 33 over 2 is equal to 65, double check, been a long day, x plus 13 times by 1.5, and again we'll leave that as 39 over 2. So if I minus 65 from both sides, that gives me x is going to be equal to 39 minus 33 is going to be 6 over 2. So x is equal to 3. Right, but what was I actually asked to work out? Work out the hourly pay before the increase. So for both of them. So Marta was 6 times by 3, which would have been 18, and K would have been 5 times by 3, which would have been 15. There we go. Okay, and if we go to the mark scheme, then we're picking up P1 is given for the process to represent algebraically Martin and Khalid's pay after the increase. So where can I award that? Right, let me just undo that. And draw. I want to take the pen off. So I can pick up that first mark for that bit there. So represent and. So I did need both parts for the P1 mark. Right, we've then got P1 for setting up an equation to be solved. So P1 for the process to find the value of x, so leading that through to find the value for x. And then A1 for the two values, 18 and 15. So there we go. Okay, question 20 then. So a race is measured to have a distance of 10.6 kilometers, correct to the nearest 0.1 kilometer. Sam runs the race in a time of 31 minutes 48 seconds, correct to the nearest second. Sam's average speed for this rate is v kilometers per hour. Considering bounds, calculate the value of v to a suitable degree of accuracy. You must show how you did your working and give your reasons. Okay, so I'm going to say that what have we got actually? So if I said the distance has to be between 10.55 and 10.65. So that's going to be the upper bound and the lower bound. And then if I talk about, I'm going to keep my time in terms of seconds for now. I'm going to go correct to the nearest second. So 31 minutes and 47.5 seconds to 31 minutes and 48.5 seconds. We want the speed in kilometers per hour, so we've got this in terms of kilometers, but this is currently in minutes and seconds. But we'll leave it like that for now. Right, so the maximum value for v. The maximum value for v max is going to be the maximum distance, so d max divided by t min, the minimum time. Right, I'm guessing this isn't going to quite work out nicely. So time on my calculator, so I'm going to use the time button. So 0 hours 31 minutes and 47.5 seconds is going to give me, as a decimal, well, that would be my decimal value, 0.5. So I want to do the maximum distance, which is going to be, I'm just double checking that I typed in the minimum. Yeah, I did. So my Vmax is going to be 10.65 divided by the answer that I've just shown, which is going to give me 20.09. So I'm going to go 20.099606. And then my V min is going to be likewise, I want the minimum distance divided by the maximum time. So that's going to be equal to, so d minimum, so that's going to be, so I'll convert my time again first of all. So we'll go 0 hours 31 seconds, 31 minutes, apologies, and 48.5 seconds. And I did need to type the 0 in. So 0 hours, 31 minutes, and 48.5 seconds. And I want to do my minimum distance, so 10.55 divided by that value. And then as a decimal, that gives me so I'm not quite sure why my calculator's not helping me out here. So let's try that again. So 0 hours, 31 minutes and 48.5 seconds. Okay, and then I want the minimum distance, which was 10.55, divided by that value, and that gives me there we go. I'm not quite sure why, if it's my calculator playing up, I can't quite work out why it's not getting that answer. So I'll try it one more time. Actually, I'm going to just restart my calculator. I'm sure it's me. Alright, let's try that again. So 0 hours, 31 minutes and 48.5 seconds gives me that as a value, and I want, realistically, that's the value that I'm after. So I'm trying to do 10.55 divided by the answer that I've just had, and that gives me there we go. Right. Let's do it one more time, and I'm actually going to use the decimal value because I'm not quite sure why it worked for part A, but isn't working for this part. So let's do it again. So 31 minutes and 48.5 seconds, and I've missed my decimal point at there. So I'm going to call that 0.5301388889, and I want to do 10.55 divided by that. So let's try it one more time. 10.55 divided by the answer that I've just worked out. Okay, there we go. Finally, so I've pressed the wrong button. 19.90044538. So if we compare these two numbers then, so if I was to round to one significant figure, they would both be 20. If I was to round to two significant figures, again, they'd both be 20. If I was to round to three significant figures, this one would be 20.1 and this one would be 19.9. So we're out. So we go to the point where they're both the same. So I'm going to go 20 kilometers per hour to two significant figures. And my reason would be as both would round to this value.